I'm going to tell you something that will completely change how you look at the night sky, something that's both disturbing and deeply profound, something that most people don't fully appreciate, even though they've heard the words before. When you look up at the stars, you see a universe full of possibility. You think life. But I want to explain why that is the greatest optical illusion in nature. The universe is not a garden, it is a vacuum. It is an ancient, frozen graveyard. The life you see on Earth, the trees, the birds, it's not a natural consequence of the cosmos, it's a ghost. It's a glitch in a system designed to be empty. Most people assume that because we're here, they must be out there too. But the physics, the actual mechanics of space-time, tells a different story. It tells us we are an impossible that happened once in a neighborhood actively trying to kill us. Now, what do we mean when we say life is an illusion? The universe has a fundamental rule called entropy. You've heard of it, but you got to understand what it actually does. Entropy is a measurement of disorder. Think of the universe as a giant room of puzzle pieces. If you shake that room for 13 billion years, the pieces don't accidentally click together to form a DNA strand. They don't form a brain. They just get more jumbled. They turn into dust. They turn into a state where no information can exist. Life is the opposite. Life is order. To be alive, you have to fight the entire momentum of the cosmos every single second. It's like building a sandcastle in a hurricane. The hurricane doesn't care about your castle. It's just doing what it does. The nothing is the rule. We are the exception. I want to talk about something that is, frankly, it's the most ruthless law in all of physics. It's called the second law of thermodynamics. You've probably heard of it. You might even think you understand it, but most people don't appreciate just how much this one law hates you. It doesn't just exist. It's a literal shredder that's constantly tearing at the fabric of everything. And its goal, its only goal, is to turn the entire universe into a flat, lukewarm, dead soup of nothing. Entropy is not just messiness. It's a measurement of disorder. Think of a steam engine. It works because there's a massive difference in temperature between the hot boiler and the cold air. That gradient is what lets you do work. But the universe is constantly trying to flatten those gradients. It wants everything to be the same boring temperature. Life is a machine that tries to build order in a system that's obsessed with chaos. To keep a single cell alive, you have to pump out massive amounts of heat and waste into the surroundings. You're basically paying a tax of disorder just to exist for a few minutes. The universe is a very, very strict tax collector. When we look for aliens, we're hoping to find another glitch in the system. We're looking for another pocket of low entropy in a high entropy ocean. But you got to understand, the universe is 99.999% flat. Most of space is just empty, high entropy void. To get life to happen once is a miracle. To expect it to happen twice in a neighborhood that's actively trying to flatten you into the background, that's not just optimistic. It's an illusion. It's a ghost story we tell ourselves to feel less alone in the dark. The chemistry we're made of is a desperate temporary revolt against a universe that just wants to go to sleep. Look, I want to tell you something about the atoms in your body that is, frankly, it's a bit disturbing. We talk about carbon-based life like it's a choice or a lucky break. We look at the stars and we think, well, if it happened here with carbon, it could happen there with silicon or ammonia or something we haven't dreamed of yet. But that's an illusion. It's a beautiful, hopeful illusion, but the physics says otherwise. The universe is not a playground. It's a strict accounting office. To get life, any kind of life, you need more than just stuff. You need complexity. You need atoms that can link up into chains long enough to carry information. And in the entire periodic table, in the entire 13.8 billion years of cosmic history, there is only one element that can actually do the job: carbon. But here's the ghost part. To get carbon, you need a very specific kind of star to live, and then it has to die a very violent death. It has to explode. Every atom of carbon in your DNA was cooked inside the heart of the dying sun that hasn't existed for 5 billion years. You are looking at a now that is built out of the dead past. Now, why does this make alien life impossible? Because the window for that cooking process is incredibly narrow. If the strong nuclear force, the glue that holds atoms together, was even 1% different, carbon wouldn't exist. The stars would either burn out in a second or never ignite at all. We call this the carbon resonance. It's a fluke inside a fluke. You're looking at a universe that had to be tuned to a precision of 1 part in a trillion just to get the raw materials for a single cell. Let's talk about the speed of light. We think of it as a speed limit, like a sign on a highway, but that's not quite right. It's not a limit on how fast you can go. It's a limit on how fast information can travel. It's the speed of causality. If the sun disappeared right now, we wouldn't know for 8 minutes. For those 8 minutes, we'd still be orbiting a ghost. We'd be tethered to a gravity well that technically doesn't exist anymore. This creates what we call the past light cone. Everything you see, every star, every fuzzy galaxy is inside that cone. But there is an enormous amount of space-time outside that cone. We call it the elsewhere. It's a region of the universe that is causally disconnected from you. You can't see it, you can't touch it, and you can't know if anything is alive there. It might as well not exist. Now, why does this make aliens impossible? Because even if there is a civilization on the other side of the galaxy, they are trapped in their own jail. We are separated by millions of light years of nothing. By the time their hello reaches us, their star might have already burnt out. They'd be a civilization of ghosts. We are looking at a map of where things were, not where things are. The universe is expanding, and it's expanding faster than light can keep up. Those galaxies we see in the deep past, they're receding away from us so fast that their light will eventually never reach us again. They're slipping over the cosmic horizon. We aren't just alone because life is rare. We're alone because the fabric of space itself is tearing us apart. We're living in a house where the rooms are drifting away from each other, and the hallways are disappearing into the dark. Look, I want you to think about the fine-tuning problem. It's the one thing that keeps physicists up at night, and it's the reason most of the math says we shouldn't be here. We have these things called fundamental constants: the strength of gravity, the mass of a proton, the energy of the vacuum. There are dozens of them, and if you nudged any one of these numbers by even a fraction of a percent, the universe would have been a dud. Imagine a radio dial with 50 different knobs. To get music, every single knob has to be turned to the exact right micron. If gravity was a tiny bit stronger, the universe would have collapsed back into a black hole before the first atom formed. If it was weaker, stars would never ignite. They'd just be cold clouds of hydrogen drifting forever. But somehow, the knobs are all in the green zone. We call this the Anthropic Principle. You might think, well, of course the knobs are right because we're here to listen to the music. But that's a bit of a circular trap. It doesn't explain why the radio was built that way in the first place. It suggests that the chance of a life-bearing universe is so small, so infinitesimal, that it's effectively zero. We are looking at a 1 in a trillion fluke. Now, here is the disturbing part. If the odds are that low, the chances of it happening twice in the same observable bubble are, they're non-existent. We're looking for aliens like they're a common feature of the landscape, but the physics says they're more like a rounding error. We might be the only ones who ever got a golden ticket in a lottery where the tickets were never even printed for anyone else. I want to talk about information. In physics, information isn't just data in a computer. It's the recipe for everything. It's the way atoms are arranged to make a star or a planet or the neurons in your brain. There's a law that says information can never be destroyed, but there's a catch. Just because it's not destroyed doesn't mean it's accessible. Most of the information in the universe is lost in a way that makes alien life functionally impossible to find. Think about a book thrown into a fireplace. The information in that book, the story, the characters, the ending, is technically still there in the smoke and the ash. If you were a god and you could track every single atom of smoke, you could read the book again. But, you aren't a god. To you, the book is gone. It's noise, it's chaos. The universe is a giant fireplace, and it's constantly turning stories into smoke. We look for alien signals, hoping for a neat, orderly hello. But space is a scattering machine. Radiation, gravity wells, and cosmic dust all act like a blur filter on any signal. By the time a message travels across the galaxy, the information has been chewed up by entropy. It's been turned into background noise. We could be surrounded by the smoke of 1,000 civilizations and would never know. Here is the kicker. If a civilization is too far away, their information doesn't just get blurry. It gets causally deleted. Because of the expansion of space-time, the distance between us and them is growing faster than their story can travel. They are drifting behind the horizon, where no signal can ever reach us. They aren't just quiet. They are in a different now. And in physics, if you can't interact with it, it doesn't exist for you. Look, let's get into the biology of the problem. Even though as a physicist I see it as just more complicated chemistry, we assume that if you have the right soup, the water, the carbon, the heat, then life is just inevitable. We think it's like a seed that just needs dirt to grow, but that's a massive assumption. We're talking about the jump from inorganic matter to a self-replicating machine. And that jump is a wall that physics doesn't like you to climb. To get a single cell, you don't just need atoms. You need those atoms to arrange themselves into a very specific low entropy structure called DNA. The odds of a random set of chemicals spinning themselves into a functional genome is like taking a billion decks of cards, throwing them off a skyscraper, and expecting them to land in perfect numerical order. It's not just unlikely, it's statistically silent. Now, why does this matter for the stars? Because even if the universe is full of Earth-like planets, most of them are probably just chemical dead ends. They've got the soup, but the spark never happens. We call this the great filter. It's the idea that there's a wall somewhere between rock and civilization that almost nobody passes. Most worlds are just stagnant pools of amino acids that never learn how to copy themselves. Here's the disturbing part. If we are the only ones who made it over that wall, it means we are a freak accident. It means the nothing one everywhere else. We keep looking for an advanced society, but the universe is likely just a trillion miles of wet rocks. We are a now that shouldn't be happening. We are a signal in a universe that's 100% noise, and that makes us the loneliest thing in existence. I want to talk about time. We think about life as a permanent thing, like a mountain or a sea. But on a cosmic scale, life is more like a flash of lightning in a summer storm. It happens, it's bright, and then it's gone before the thunder even reaches your ears. The problem with finding aliens isn't just about where they are, it's about when they are. And the physics of timescales is a very lonely thing to think about. The universe is 13.8 billion years old. Our planet has only had complex life for a tiny fraction of that. If you squash the history of the universe into a single day, humanity doesn't even show up until the last few seconds before midnight. Now, think about the odds. For two civilizations to talk, they don't just have to be in the same neighborhood. They have to exist at the exact same microsecond of cosmic time. If a civilization on a distant star lived for 1 million years, which is a long time for us, but they died out 500 million years ago, we'd never know. Their radio signals would have passed our location while we were still looking like single-celled sludge. We're ships passing in a very dark, very fast-moving night. By the time we developed the ears to listen, the voice on the other end was already a ghost. Here is the ghost reality. We are looking at a causal mismatch. Most of the life that could have existed has probably already been erased by entropy. And the life that will exist hasn't even been cooked in the stars yet. We're living in a tiny accidental window of light between two infinite oceans of darkness. We're reaching out a hand to a neighbor who hasn't been born yet or who has already turned back into dust. We need to talk about the Goldilocks zone. It's a term you hear all the time. The idea is that if a planet is at the right distance from its star, not too hot, not too cold, then life is basically a sure thing. We see these planets on the news and we think, there it is. Another Earth. But that's an illusion. It's a dangerous oversimplification of the actual physics. Water is just a solvent. It's not a miracle. To get a world that can actually hold a low entropy system like life, you need 1 million other things to go right. You need a magnetic field strong enough to stop the star from peeling away your atmosphere. You need a moon big enough to stabilize your tilt so the seasons don't go haywire. And you need a Jupiter nearby to act as a cosmic vacuum cleaner, sucking up all the rocks that want to smash you back into the Stone Age. Now, why does this matter? Because when you run the math on how many Goldilocks planets actually have all those extra layers, the number collapses. We aren't looking at billions of Earths. We're looking at a handful of lucky rocks. Most of those planets we find are actually hellscapes. They're tidally locked, with one side baking in radiation and the other frozen in a permanent night. They aren't habitable. They are causal dead ends. Here is the ghost part. We keep looking for our twin, but we forget that Earth is a four-dimensional freak show. It's not just about the where, it's about the perfect alignment of gravity, chemistry, and timing. When we look at those fuzzy dots in a telescope, we aren't seeing a home. We're seeing a phantom. We're seeing a place that looks right but lacks the heartbeat of a real planet. We're looking at a reflection of our own hope, not the reality of the vacuum. Look, let's assume for a second that I'm wrong. Let's assume the soup works and the entropy doesn't kill it. You get a planet covered in green slime or bacteria. That's great, but there is a massive difference between life and intelligence. We talk about them like they're the same thing, but they aren't. In the 3.5 billion years life has been crawling around on this rock, intelligence only happened once. It's not a natural end goal. It's a freakish detour. In biology, evolution isn't trying to make you smart. It's just trying to make you stay alive long enough to make more of you. Most of the time, being smart is actually a disadvantage. Brains are expensive. They eat up 20% of your energy just to keep the lights on. For 1 billion years, sharks and crocodiles have done just fine without knowing a single thing about quantum mechanics. They are perfect machines. They didn't need a soul. Now, why does this make aliens impossible? Because the jump from slime to radio telescopes requires a perfect storm of accidents. You need a stable climate, a specific gravity, and a species that has the hands to build things. If you're a super intelligent dolphin in a frozen ocean under the ice of Europa, you might be a philosopher, but you're never going to build a rocket. You're trapped in a biological jail. Here is the ghost reality. The universe could be full of life that is silent, not because it wants to be, but because it has to be. We're looking for a conversation, but we're probably surrounded by 1 billion sharks. We're looking for a peer, but we're just a now that happened to develop the ability to scream into the void. The intelligence filter is the final door, and it looks like it's bolted shut from the other side. I want to talk about the expanding universe. Most people think of space as a stage, a big empty room where the stars are just there. But that's not what Einstein showed us. Space is a thing. It's a fabric. And right now, that fabric is stretching. It's getting bigger every second. And the thing doing the stretching is something we call dark energy. It's a mysterious force that acts like anti-gravity. It's pushing everything away from everything else at an accelerating rate. Now, why is this a divorce? Because eventually, those distant galaxies we see, the ones that might have had life, are going to be moving away from us faster than the speed of light. Now, you got to understand, they aren't moving through space that fast. It's the space itself that's growing between us. It's like two ants on a rubber band that's being pulled apart. The ants are walking toward each other, but the rubber is growing too fast. They'll never touch. This means the observable universe is actually shrinking. Every day, more stars slip over the cosmic horizon. They enter the elsewhere, and they never come back. Their light can't reach us anymore. They are causally deleted. In the far future, an astronomer on Earth, if there is an Earth, will look up and see nothing, just a black, empty sky. They won't even know other galaxies exist. They'll think they are the only thing in the entire cosmos. Here is the ghost reality. We might be living in the only tiny window of time where a hello is even physically possible. We're reaching out to a universe that is literally tearing itself into pieces. We're looking for a neighbor while the houses are all drifting into the dark. We aren't just looking for aliens, we're racing against the final silence of the vacuum. And the vacuum, it has a massive head start. Look, let's talk about the radio illusion. We have this idea that a signal, a hello from a distant star, is like a laser beam that just travels forever until it hits our ears. But that's not how the physics of information works. Space is not empty. It's full of interstellar medium. It's full of dust, ionized gas, and the echoes of dead stars. When a signal travels across the galaxy, it doesn't stay crisp. It gets chewed up. Think of a shout in a crowded, noisy stadium. If you're standing right next to the person, you hear every word. But if you're on the other side of the field, all you hear is a faint, meaningless hum. The information has been scattered by the air and the noise of the crowd. Space does the same thing. Every light year of distance is another layer of signal decay. The inverse square law tells us that the strength of a signal drops off exponentially. By the time it crosses the void, it's weaker than the background static of the Big Bang. Now, why does this make aliens impossible to find? because a civilization would have to pump out an insane amount of energy, the output of an entire star, just to be heard above the noise of the universe. They'd have to be screaming into a megaphone the size of a solar system. And why would they do that? Why would a civilization waste all its energy talking to a now that won't exist by the time the message arrives? Here is the ghost reality. We aren't looking for a signal, we're looking for artifacts in the noise. But the nothing is a perfect eraser. It takes every hello and it turns it back into entropy. It turns logic back into static. We keep waiting for a voice, but the universe is a giant muffler. We're looking for a light in a fog that is 100,000 light years thick. We aren't just lonely because nobody's talking. We're lonely because the universe doesn't like the sound of a voice. I want to talk about the black hole of distance. We've talked about the elsewhere, but you got to understand the actual cost of space-time. Even if light travels at 300,000 kilometers a second, the universe is growing faster than that light can bridge the gap. We are living inside a cosmic bubble. Everything outside that bubble is moving away from us at superluminal speeds. It's not just far, it's functionally unreal. Think about a black hole. You know that once you cross the event horizon, you're gone. No light, no information, no hello can ever come back out. The universe has the same thing, but in reverse. It's called the cosmological horizon. There are stars and galaxies out there right now that are slipping over that edge. They are causally deleted. You can't see them, you can't talk to them, and you can't even prove they're still there. Now, why does this matter for the aliens? Because it means the universe is a fragmented reality. It's not one big place where everyone can meet for coffee. It's a collection of isolated islands that are drifting apart forever. If a civilization is on one of those islands, they aren't just neighbors. They are in a different universe. They are outside our past light cone. They are ghosts that haven't even been born in our timeline yet. Here is the ghost reality. We keep hoping for a galactic empire, but the physics of dark energy says that's a hallucination. The information of the cosmos is leaking out of our bubble every single day. We are looking at a map that is constantly being erased from the edges inward. We are searching for a now in a room where the walls are moving away faster than we can run. We aren't just lonely, we're causally stranded. Look, I want to bring this back to the numbers. In physics, we have these things called the dimensionless constants. They're just numbers. They don't have units like meters or seconds. They're just, they're the settings of the universe. Things like the fine structure constant, which governs how light interacts with matter. If that number was even slightly different, you wouldn't have atoms, you wouldn't have chemistry. You just have a soup of radiation that never goes anywhere. We talk about alien life like it's a variable we can solve for. We use the Drake equation to estimate how many civilizations are out there. But that equation is a lie. It's a hopeful human lie. It assumes that the probability of life is a stable number. But the physics of the multiverse suggests something much more disturbing. Most universes, the vast infinite majority of them, are duds. They're born, they expand, and they die without ever cooking a single atom of carbon. Now, why does this matter for us? Because it suggests that we are a statistical anomaly. We aren't the standard version of a universe. We are the 1 in a trillion version, where the knobs were all accidentally turned to the exact right micron. It's like finding a single perfect snowflake in a furnace. The furnace is the rule. The snowflake is it's the glitch. To find another snowflake in the same furnace is, it's not just unlikely, it's physically impossible. Here is the ghost reality. We are looking at the stars and waiting for a reflection of ourselves. But the nothing between those stars is the actual reality. The vacuum is the normal. We are the abnormal. We are the only piece of the universe that has woken up enough to realize how cold it is outside. When we look for aliens, we're hoping the universe isn't as cruel as the math says it is, but the math doesn't have a heart. The math just has entropy, and the entropy always wins. We're at the end. We've looked at the entropy, the causal jail, and the shredder of the vacuum. And it paints a picture that is, frankly, it's terrifying. It suggests that we are alone on a tiny, fragile rock, floating in an infinite graveyard. We're reaching out to a now that doesn't exist, looking for ghosts in a sky that is mostly just nothing. It seems like a tragedy. It seems like a cruel joke of the cosmos. But I want to tell you why this is actually the most beautiful thing in physics. The fact that the night sky is an illusion, the fact that we only see the past, is not a limitation. It's a gift. Because the speed of light is finite, the universe is a cosmic archive. Every photon that hits your eye is a messenger from a time before you were born. By looking at the nothing, we are actually looking at the history of everything. If light traveled infinitely fast, we'd only see the present. We'd have no access to the deep past. We'd have no way of knowing where we came from. But because the universe is a time machine, we can watch the stars being born. We can see the afterglow of the Big Bang. We can see the very moment the first atom was cooked. The aliens might be impossible, but the information is real. We are the universe's way of looking at itself in the mirror. So here is the real truth. The stars are optical illusions. They're ghosts at phantom locations from ancient times. They aren't real in the sense of showing you the present state of the cosmos, but they are the most truthful illusions in nature. They tell us that even in a universe of entropy and death, order happened once, we happened once. And in a vacuum that's billions of light years wide, that is more than enough.